Lesson 1-3 is writing expressions. And first we're going to go ahead and look at the different operations and what the expressions are actually talking about. So for addition, you can think of many different words that mean addition, and here are just a few of the keywords that mean addition. We can have sum, plus, total, more than, and increased by. So all of those mean addition. So if we look at the verbal phrase, it says the sum of two and a number x. Well, we know that sum means addition, so the sum of 2 and a number x should look like this: 2 and a number x, or a number n plus 7. It's pretty basic. You just write down the n plus 7. Subtraction, a few different words that mean subtraction are difference, less than, minus, and decreased by. Subtraction, addition, the order doesn't matter, so technically 2 plus x, x plus 2 is the same thing. But for subtraction, order definitely matters. When we say the difference of a number n and 6, the n is going to come first because it's the difference of that number and 6. So this needs to be n subtract 6. And then here we have a number y minus 5. So the y has to come first, y minus 5. Multiplication is times, product multiplied by, and the little word of. This also means multiplication. So 12 times the number y, you can just put the variable and the coefficient together and it's just 12y. It's okay if you go 12 and then dot y. Don't use an x though, because we're talking about variable expressions right now and we don't want an x in there to mean multiply. 1/3 of a number x, 1/3 of means times, so it's just 1/3 x. Division is quotient, or we could say divided by or divided into. So the quotient of a number k and 2 is going to be k over 2. I want you to get in the habit of writing these quotient expressions with a fraction bar. Very rarely in algebra will you see k and then the division sign with the 2 or a number. Alright, let's go ahead and practice doing some of these. So here it says translate the phrase the quotient when the quantity 10 plus a number x is divided by 2. So we're going to translate this into an expression. So we're looking at the quotient when the quantity of 10 plus a number of x, 10 plus x, quantity is another name for parentheses. So I want the quotient when this quantity is divided by 2. So there's the quotient, and we're actually dividing by 2. Here, the situation, the amount of money you earn per hour if you make D dollars in 15 hours. So you're going to make a total of D dollars in 15 hours. So I need to make sure that I take the number of dollars that I have earned, the total, and it says the amount of money you earn per hour if you make D dollars per, like total, and we're going to divide it by the number of hours. So for example, and this will give me the total that I make per hour. So sometimes it helps me if I do an example. Let's say that I make $150 and I work for 15 hours. This tells me that I made $10 per hour. Again, sometimes it helps me if I actually work out a physical problem, an exact problem. The total cost for 4 people to ride a bus if the fare of 75 cents is increased by D dollars. So it's going to be 4 people riding the bus, so 4 times the 75 cents increased by, that's addition, D dollars. So 4 times, because it's for 4 people, and then 75 cents plus D. Okay, next we have a rate is a fraction that compares two quantities measured in different units. If the denominator, if the denominator of the fraction is 1 unit, then we call it a unit rate. And here we're going to go ahead and figure out what the unit rate is. So what I want to do is I want to change this into, instead of 220 students in 8 classes, I want to know how many students in one class. So what I need to do is divide by 8 over 8. The reason I'm not just dividing the fraction by 8 is because then it would only divide the numerator, and technically I need to turn this into a unit rate, so I need my denominator to be 1. And again, when I divide any number by itself with the exception of 0, I do get a 1. So 220 divided by 8 gives me 27 and a half. Oops. Students per class. No, you can't have a half student, but statistically, statisticians, they look at halves, fourths, etc. So 150 plastic cups in 3 packages, I want to know how many per package. So I'll divide by 3 over 3. 150 divided by 3 is 50. So it's 50 cups per package. Now, in some cases, you're not going to be, you will find a unit rate, but they're going to change the units on you. Here we have 120 miles in 2 hours, but I want to know, clear down here, how many feet per second. So I've got to change miles per hour into feet per second. So what I'm going to do is, the first thing I'm going to do is I'm going to change hours to seconds. So I know, actually I'm going to change hours to minutes. So I'm going to do it a little bit slower. I like to show my whole process. So I'm going to change hours to minutes. And I know that in 1 hour there are 60 minutes. So what I can do right here is I can cross off the unit of hours. So I've changed this now so that it's in minutes. I want it to be in seconds, so I know that there are 60, whoops, backwards, I'm sorry. In 1 minute, there are 60 seconds. So now look what I can do. I can cross off the minutes with the minutes. So far, if I look at the top, I've got this, my units are miles per second. So I'm almost there. I have it in seconds, but I need to get it in feet per second. So I have to keep going. I know that in a mile, there's 5,280 feet. So I know that 5,280 feet are in 1 mile. So now look what I can do. It's clear across the board, but I can still cross off miles with miles. Now my units in the numerator are feet, in the denominator they're seconds, and I simply have to do the arithmetic. So I have to take 120 times 5,280, and that gives me a huge number, 633,600 feet per 2 times 60 times 60. And that's 7,200. Well, now, since they want it as a unit rate, I have to divide both the numerator and denominator by 7,200. So when I do that, 633,600 divided by 7,200, it gives me 88 feet per second. So again, I knew I wanted feet per second. I worked on getting the seconds first, and then I worked on getting my feet. If you can do it simultaneously, you're welcome to, but my brain needs to process it just a little bit at a time. Let's go ahead and do another one of these. I again want feet per second. But right now I have yards and hours. I'm going to change my hours into seconds first. I'll do it the same way. I know in 1 hour there's 60 minutes. So I can cross off my hours, and I know in 1 minute, come on, there's 60 seconds. So I can cross off my minutes, and now I at least have seconds. Now I need to change my yards into feet. And I know that there's 3 feet in 1 yard, so 3 feet in 1 yard. So I can cross off my yards, and now I have it feet per second, which is what I'm aiming for. So I'll take 240 times 3 in the numerator. 240 times 3, I hit division, is 720 feet. And in the denominator, I have 60 times 60 is 3,600 seconds. But again, for a unit rate, I need to divide now by 3,600 over 3,600. So 7,200, or I'm sorry, 720 divided by 3,600 is 2/10 of a foot per second. 2/10 of a foot per second. Okay. Now we're going to write an expression and then actually evaluate it. You're setting up a children's painting class. Poster board paints cost $3.80 for each child, and a package of 100 sheets of poster board costs $66.50. Assuming that you only need one package of poster board, and we know that that's $66.50, we need an algebraic expression for the total cost of supplies. So we know it's a given $66.50 plus it's $3.80 per student. So I'll use an S for per student. So here's my expression. Now I need to find the total cost if I have 18 students. So $66.50 plus $3.80 times 18. So that's $66.50. We know that we're going to do the multiplication first. 380 times 18 is $68.40. So my total is $134.90. And don't forget, when you do this, you have to label it. In this case, it's dollars. Anytime you have an application problem, it should be labeled. All right, that's it as far as notes. If you choose to start it, you have lesson 1.3. Again, we're going to do the worksheet.